Next conic section looks like it's not a circle because we see some wobbling here. All right. This one has a minor excess of 2. This one has a major excess of 3. So that creates a distortion to the circle. There's some kind of like, I don't know, think of it as like some gravitational pressure or something. And so this guy's good to go because he's in standard form. This guy's in general form. So they're both going to be ellipses but different forms. Now this one's easy. It's totally amenable to graphing because that's what standard form is like. So we go, the center of the ellipse is -2. We're going to move over -2. And then we're going to go up 3. Okay. And going up 3 now means that if on the x-axis I go 2, 2, and 2, on a circle I would go up 2, down 2, but in this case I'm going to go 3. So 3 here and 3 here. So we got a slight distortion to the circle that looks like that. All right, now this is different because now here's where we get into something I would say significantly more complex now, because we're going to have to group the x's with the x's and the y's with the y's. Okay, but that 3y squared is going to kind of pose an issue that a lot of people do forget how to do it because completing the square is such a weird thing. It's like it's something that has to be kind of memorized. Okay. Now this is the setup that happens when you have something in general form, and it's going to be true with the hyperbola as well. But I want to move that 17 over to the other side, okay? And these problems are like engineered to be graphable, okay? It's just that they're in this general form. You show you're completing the skill, completing the square skill so that you can get it to this guy. Okay, that's our goal. Okay, now this guy is pretty much good to go. All I got to do is take that 2, divide by 2, and then square it, just like we did with the circles. And that's going to give me a +1, and what we'll do is we'll add that +1 there. Okay. Then what we got to do is we actually have to, we need the a in front here to be 1, just like it is here. This guy is not. I need to factor out that 3 in order to make this work. Okay. So if your numbers are kind of large here, you've got to get rid of whatever this guy is in order to make it work. And this guy better be divisible by this guy, or else you use a calculator. You just go straight to technology because it's not working out smoothly. You're going to make an error. I mean, decimals, like this stuff is just not going to have decimals. All right. So what we need then is we need to add a number here that will produce a perfect square trinomial. So again, just like we did here, divide by 2, square it, divide by 2, square it. -2 divided by, or I'm sorry, -4 divided by 2 is -2. -2 squared is +4. Okay. Now what you also have to remember though, and here's where a lot of people make mistakes, especially if they haven't done this in a while, is that 3 times 4 is what you're adding to the left. It is not just 4, you are adding 12. Okay, you're not adding 4, you're adding 12. So we have to make sure that we add 12 to that side. Okay? Okay, now this is going to give us a perfect square trinomial. Okay, so take the square root, take the square root, take that sign, and there he is. So we know this ellipse moves over to the left 1. Then what happens? We've got plus, we've got a 3 up here, and now we've got y minus 2. Quantity squared equals 30. Okay, 30 is not enough. We have to change him to a 1, so let's divide both sides by 30. And what we get is we get x plus 1 quantity squared over 30, plus now these two will go into each other, so that's a 1 over 10. Okay, and that equals 1. Now this guy is graphable, kind of, because what we've got here is we have a situation where I needed the square root of 30 to tell me how far to the right and left I go. So I'm going to have to estimate what the square root of 30 is. Okay. Now you could use a calculator, but actually, it's like I think it's going to be like 5.4. It's going to be pretty close to the middle here. So let me just verify that. Okay, so 5.5 probably would have been better. So 5.5. So this means then that we'll go 5.5 over to the left, which is about there, and then we're going to go the square root of 10, which is 3.2, I think, if we round up, but let's just verify that. All right, 3.2. So then we're going to go up. Nope. Up and down 3.2. So we're going to go to the right and left. Okay, just a second. Let's get those numbers here. We're going to go 5.5. This one is 3.2. Okay. So I'm going to use that, and let me zoom out a little bit. Okay. So my center has shifted from over 1 up to, so I'm here. But now I have to go 5.5 to the right and left. 1, 2, 3, 4, 5.5. 1, 2, 3, 4, 5.5. And then I'm going to go up 3.2. 1, 2, 3.2. 1, 2, 3.2. Okay. All right. There we go, and that's it. Okay. Now we have a hyperbola because we do see that that is subtraction. As soon as you see subtraction, I see subtraction here, I see subtraction there. This guy is now going to go like this or like that. Okay. All right, now because the y squared is first, that means that I have to have that. Okay. Y squared is going to look like that. X squared would look like this. So this guy is going to be that formation. Okay, we go either right up and down or side to side. Okay, so now with this then, I don't have to do any completing of the square. I will over here though, but only for one of them, which is nice. I only have to do it for y because x, he's all by himself. But now what I need to do is move over to the center of this hyperbola, and the center is actually 0, 0. Okay. But now I got to do the square root of 20. Okay. And the square root of 20 will tell me how high up and down I go. Now, why is it high? Because I am underneath the y coordinate, so that tells me up and down, just like over here when we did 10, that told us up and down 3.2. We're under the y. And just because y is first does not mean that we're not going up and down. It just means that we have this formation, okay? Because remember, with subtraction, order counts. So we said the square root of 20 is, we didn't say yet. So radical 20 is 4.5. Okay, and then radical 5 is 2 point something. 2.2. All right, now that's just basically estimates for me going up and down. So 1, 2, 3, 4.5. 1, 2, 3, 4, 4.5. And then this guy goes over 2.2 and 2.2. Now remember that this, for a hyperbola, means that I will be drawing a box. Okay, I'm drawing a box, and I'm going to go ahead and make it solid just because I'm using a pencil, and I'm going to draw those guys there. Okay, and we create kind of this no-fly zone, and we said that we've got this formation. So what's really nice about this, just go ahead and make those guys jump off to the side. You don't even have to worry about what points they pass through. What you've done is you've shown the general formation of this guy. This is absolutely good enough because the asymptotes really just kind of tell you that it just kind of hugs those lines as you go across. Okay, all of these are decimals. Okay, almost all of them are. So that's that. This one, I'm going to have to complete the square now. So let's do that. Okay, so 4x squared, he doesn't need anything. There's no other x term. So I'm going to go straight to the negative 25y squared minus 150y. And then I'm going to put that 325 over to the other side, and he will become negative. Okay, now, because this is a hyperbola, though, I'm going to have to pull out that 25, and it's got to be negative, which makes that negative 150 a positive 150. All right, and if I had $1 for every time somebody messed that up, I mean, it just happens all the time. In fact, I just messed it up because if I'm taking out a negative 25, why would I write 150? How many, what is that, 6? Yeah, let's fix that. That should be a 6, okay? 6 times 25 is 150. Okay, so next, what I want to do is I want to complete the square, so I take that 6, divide it by 2, and then square it. That gives me a 9. Okay, so plus 9. Okay. Just making sure this is correct here. Positive. Dividing 9. Okay, so what is 9 times 25? For some reason I was thinking that was larger than 325, then it would have been a negative number. Okay, it's not. It's 225, so I've got 225 over here. But notice, though, that I did add the negative 225 because that is negative 25 times positive 9. So that's here, okay? Now, I know I might be going a little quick, but, you know, this is review. So, you know, if you did forget this stuff like cold, like it's gone, you might want to, I mean, there's lots of other videos that you can watch, not just me, and these examples you can kind of get your feet wet if you're concerned about this part of the test, okay? But honestly, it's going to be a very small portion of the test. I wouldn't worry too much about it. All right, so now we've got that perfect square trinomial. Take the square root, take the square root, take the sine. Remember, the 6 is only used to get the 9. The 9 is used to get the 3, okay? All right, now divide everything by 100 because I need it equal to 1. Why? Because that's just the general form. That's how everything works out beautifully. So we get x squared. 4 goes into 100 25 times, so 25 will go here. And then 25 goes into 100 4 times. Funny how that works out beautifully. And then that is 1. So now we're ready to graph this hyperbola. And because the x squared is first, this means that this guy is going to go side to side. Okay, side to side. So let's go ahead and graph this guy. Fold this. Put it here. Okay, so move that guy out of the way. Looks like we are not moving to the right or left, but we are moving down 3. So right here. And then what I will do is use my pencil, first of all, because I need to go over to the right and left 5, right and left 5, and I'm going to go up and down 2, and then I have my box. This is the no-fly zone. This is where the hyperbola is not. Okay, if you have no coordination, I would encourage you to use a ruler. But as we are here, I'm going side to side. This is good enough because I know that I'm going to go off to the side right here. Okay, and just go ahead and hug those asymptotes approaching it. Okay, and that is it. That's all you got to do for the final exam. And we'll do the last two in the next one.